of anyone who perhaps is not able to make it but interested in attending Dr. Cox's presentation today, they'll be able to access that after today's session. So again, we are so happy to have you here. I'm going to turn it over to Guafong, who's going to introduce our speaker for this afternoon. Thank you.
Good afternoon, everyone. It is my pleasure to introduce our speaker today, Professor Sarah Cox. Dr. Cox is an assistant professor of special education at Michigan State University with a research focus on supporting students with autism in academic setting. Specifically, her work focuses on evidence practices that enhance mathematical outcome for school students with autism. Before joining Michigan State University, Dr. Cox was an assistant professor at Eastern Michigan University and also completed her postdoctoral fellowship at Florida State University. Her research has garnered support from organizations such as the Organization for Autism Research and the Institute for Educational Science, highlighting her contribution to the field of autism and special education. Dr. Cox is also a member of the editorial board for education and training in autism and developmental disabilities, and actively contributes to the Science of Math organization, where she advocates for research-based instructional practices that benefit students with disabilities. Her work not only aims to improve educational outcomes, but also promote a deeper understanding of how to support the diverse learning needs of students with autism in inclusive settings. Please join me in welcoming Dr. Sarah Cox.
Thank you so much. What a nice introduction. It's always fun to have someone explain or like share out some of your accomplishments. Makes you feel good about yourself, fills your cup for the day. Okay, so thank you. That was a lovely introduction. Just to add a little bit more, I know I recognize several of the names in this room, so it is nice to see your names, even if I'm not seeing your faces. For those of you who are not familiar with me or we've not had the opportunity to meet before, in addition to being an assistant professor of special education, I teach the math methods course here at Michigan State University. And I am also the parent of two children with exceptionalities. I have a son who is on the autism spectrum and is one of the main reasons that I joined DADD to begin with, which was before my journey started. I should say my doctoral journey started with research. And prior to that, I was a middle school general education math teacher for several years. So that is kind of my background. It's what led me here today. Thank you for joining us. I know that October can be a very busy time, especially for anyone in education or with families who have children in educational settings. So I hope that you will find today's session valuable. In the chat, you will see a link to the Google Drive, and within the Google Drive, you have access to these slides, which will include hyperlinks to several of the resources that I'm talking about, as well as some of the resources themselves. Okay, sorry. All right. I think if I move this over here, if I move this little bar of myself, can you see the bar right now if I leave it where it is? No? Okay, then we're gonna let it go. Okay, so for today, these are the topics that I'm hoping that we can cover. I'm gonna go through a little bit of an introduction just to make sure that you all understand the motivation for me, because I think everybody has different motivations for why this topic may be important for them. I'll talk a little bit more about what math language means when I'm talking about math language. Then we'll go through some specific strategies and resources. And then last but not least, hopefully, my goal is to leave enough time for a discussion / question answer period as well. All right, so when I am talking about math language for students with ASD, one of the first things that I want to bring to attention is the fact that we have a medical diagnosis of autism spectrum disorder as well as the educational eligibility umbrella. And so I know for many of you, this is a review, but for anyone who may not be familiar with this means that there's kind of two models. So in the medical model, in order to qualify for, let's say, services through like your private insurance, you need a medical diagnosis of autism in order to potentially have insurance reimburse those expenses. On the other hand, that medical diagnosis does not in and of itself guarantee that the student will also be eligible for an individualized education plan under IDEA. There's a slightly separate category for that. And each state has slightly different ways of reviewing what that looks like. So what that means in practice is that we have students who have characteristics of ASD, who may or may not already have a medical diagnosis, who are in general education classrooms, who may or may not be receiving educational services. So it is really important for all of us to be considering how we are inclusive within our classrooms and how we are providing access, even though an eligibility decision may or may not have been made. And all of that on top of, we know that prevalence is increasing. So the most recent CDC report says 1 in 36 individuals have an autism spectrum diagnosis. All right, so this is just a really quick snapshot. Again, I know that we all have very different backgrounds and experiences with this. So I know that when I first started this, the idea of looking at mathematics for students with autism was a little odd because many people had this belief or assumption that individuals on the autism spectrum were very gifted at math or might be savant-like in math. And what we have seen over the last couple of decades is that, in fact, there are individuals who may meet that profile, but they are far fewer than students who have an ASD diagnosis who experience math difficulties, and also it's more likely to have a mathematics disability on top of that. So this is a graph from a recent study that we just did. About 15 local districts participated with us. We had just under 200 students with autism spectrum disorder, and we just ran the data in terms of their proficiency as defined by our state tests. So I am not calling them advanced proficient, partial, or not. That is the label that the state gives them. So essentially, the goal is that we want all students to meet proficiency. In other words, we want them to be proficient in mathematics as defined by the state in terms of mastering those curricular standards. And what we see, that pink and maroon solid bold line, we see in third grade, almost 70% of them were advanced or proficient. That's a very large percentage. And in fact, that was very equal to students in other disability categories and not that different than students without a disability diagnosis. However, we see that there's this very large drop in fourth grade, again in fifth, plateaus a little bit in sixth grade, and then by seventh grade, only 10% of these students were proficient in mathematics. So this is consistent with what we see in the broader literature that students with disabilities, especially those with autism spectrum disorders, are experiencing difficulties in mathematics later in their school years. And so this is something to pay particular attention to. So, which leads me to math language, because there is a theory, an idea that the language of mathematics is particularly challenging and may be contributing to many of the difficulties that we're seeing students face as we get into these more complex and abstract topics. Okay, so when I talk about math language, oftentimes, I know I have several reading specialists here in the audience, so I'm going to try not to mess this up too badly. Language is not just vocabulary, right? As a math person, I think of language as either spoken language or maybe as what I am reading or vocabulary, but it is far more complicated than that. When I'm talking about math language, I am primarily talking about vocabulary, whether formal or informal, and the pragmatic application of these mathematical concepts. Okay, so I've given the example of perimeter. We might need to teach students what does it mean to have the perimeter of a particular shape. And then the pragmatic application of that would be finding the perimeter of the fence that goes around the yard. They'd have to be able to understand the pragmatic application of what it means to find the perimeter. Why is math language important? Well, it provides access to instruction because most of our instruction is through language, whether it is written or spoken or in peer conversations, gestures. There's all kinds of ways that this information is being translated through this language. It also is used by students as they're connecting concepts. So as they're understanding what perimeter means and they're making connections in their brain of what perimeter looks like in different environments, they're using language in addition to visuals to make all of that happen. And then that comprehension is occurring both through receptive and expressive learning opportunities. So I'll talk a little bit more about that expressive piece. But the idea of not only are they receiving information, but they also have to then translate that information to provide you, their teacher or their parent or their peer, with evidence of their own understanding of that math as part of this learning process. All right, why might it be difficult for students with ASD? The number of terms, just the sheer number of terms. Sarah Powell and colleagues did a study recently that by the 5th grade, students have approximately 500 new math terms that they have to learn, which is a huge number of just new vocabulary for any student to learn. And then on top of that, these terms are growing in complexity and the abstract nature of what that mathematical concept is. And as I mentioned before, this language is used in many different modes. And so thinking about how it is presented through those modes can be helpful. The posters at the bottom are from the the state of Virginia has word walls that they have available. And if you click on any of those pictures, it will take you to that link of the word walls. They have them available in PDFs and Word documents. Okay, so what I am going to kind of dig into today is a recent article that co-author Elizabeth Hughes at Penn State and I wrote that breaks down a little bit more what this might look like in a classroom, in a general education math classroom, especially in the middle school level when we are supporting students with ASD. So what we did was we cross-referenced the IES practice guide. So these are practices that have scientific evidence behind them, and then it rates how strong that evidence is with evidence-based practices for students with ASD. And we tried to see where these two things overlapped and how we could provide some examples of what direct instruction or visual supports or modeling might look like within the guidance provided by IES. Okay, so I've linked to those two resources there as well. And this is kind of my caveat here that what I am about to present to you is not empirical evidence. We have very limited empirical evidence that talks about mathematics instruction for students with ASD in general. And the limited amount that we do have that shows vocabulary or language at all really is based on vocabulary that does show a potentially positive outcome. But I need to give that caveat to say that this is not empirically based. This is primarily theoretical and preliminary driven, and therefore please continue to monitor your own individual students' progress and determine whether these are working or not working. All right, so recommendation 1 from IES was to teach essential vocabulary. The link up there, that little picture and link will take you to the National Center for Intervention, which provides at the beginning of each of their intensive intervention math lessons, they provide a list of vocabulary words that the student might need in order to access those materials. When you are planning for explicitly teaching vocabulary, some things that you need to think about are, when is this going to be included within the lesson? What terms are you going to focus on? And how are you going to facilitate this new knowledge? Okay, so timing wise, we have evidence that this can be effective before, during, or after. We have a ton of empirical evidence for kids in general in terms of effective vocabulary instruction, including with students with disabilities. We don't have a ton specific in the math domain for students with ASD, but based on prior research, we have reason to believe that it would be useful before to kind of prime students for what they're about to learn. During, meaning that making sure that if you're getting formative feedback that the student does not understand what a term means, you can stop and break down what that term means. And or after, if you get some kind of feedback from the student that they do not understand a word, whether it is through a work sample or whether it's as you're discussing with them or through a peer interaction, you can stop and provide that instruction right there. If you are unsure which terms might be helpful for students, or if you're unsure how to use a student-friendly definition, the Common Core State Standards has a math glossary that is a good resource. There are often instructional tasks, whether from a particular curriculum company. The NCII module before had some terms as well. If you are a teacher and if you're planning your lesson, you can stop and look through that task and think about what are some of the terms that are maybe prerequisite knowledge that you don't teach in that lesson particularly, but maybe you need to pre-teach for students to make sure that they remember what that term was from before. And then in terms of how we are helping this vocabulary along, we are explicitly connecting terms together. So if they are learning a new term, we're trying to connect it to prior knowledge because we know that connecting it to prior knowledge is a way to help them maintain that long-term memory rather than in just short-term memory. And then between those terms specifically, which is going to help with generalization. So how do they know the difference between perimeter and area, for example? How are those things related and not related? And then we are practicing using the terms when learning and doing mathematics. And my children will tell you this is not their favorite thing that their mother makes them do, but it is very important. All right. So what does it look like to teach vocabulary? What are some different strategies or supports? So graphic organizers is one of the strategies that we have the most evidence to support it being a very effective way to support vocabulary instruction. One type of graphic organizer is a Frayer model. Again, for all my reading people, I'm sure this looks very familiar. Here in mathematics, we are using it to define the term or to name the term in the middle, excuse me, provide a definition. You can include a textbook definition underneath if you want, and then characteristics of what that term is in the top right. Bottom left gives some examples and bottom right gives some non-examples. So we're pulling in some explicit instruction here as well because we are trying to think through what are some really clear examples that we're trying to make sure students recognize. And then these non-examples are often aligned with common errors that we might see students make or common misconceptions that we can use this opportunity right here in this Frayer model to kind of help them along. I wrote out this Frayer model with the idea that when I used to do this in a classroom, I would have students keep like a dictionary, basically a Frayer model dictionary, and then each day was a different color. So as they were learning so if we did linear functions one day and the next day we did inequalities or whatever it was that we did, then they could come back to each of these terms and in a new color refine their understanding of what this term does and does not mean. And a blank version of that Frayer model is available for you within the Google Drive. A second graphic organizer type that we can use to teach vocabulary is a mind map. And this mind map was created specifically for division, and it was created to try and connect these different terms. So I talked earlier about it's really important to help students understand the relationship between terms as well, so that they can understand mathematics more holistically instead of individually. It will help with that progress as they go along. So you can see here that division is in the middle, and then each of the different parts of this division equation are included here. So what does a divisor look like? What does it look like in different ways? How can I explain what this divisor is? So this is just an example of what division might look like. Again, this is something that you can do individually. You can do this as a whole class. You can do this as different vocabulary words come up. I've seen teachers have like big sheets on their bulletin boards, and students will go up and add new information as they are learning about different problems. Or if they have a really good example from that particular day, they'll have a student go up and write that specific example or provide that additional clarity within a specific word wall. I have also seen teachers use this very successfully in digital environments. So there are many mind map graphic organizer programs out there that will hold onto these word walls for you. I used Canva to create this one, but there's other options as well, and then students can keep it that way too. All right, another option, I mentioned word walls before, but word walls and or explicitly pre-teaching. So again, I know that schools have very different structures and systems, and so how this looks within your specific setting, whether you're in a school or whether you are working with students in a more tutoring type setting or at home, you can pre-teach words to help them when they get into the classroom and the teacher starts providing instruction on equations and expressions. You're priming them to pay attention to those key differences that the teacher might be pointing out. And then afterwards, you can create some kind of visual to save in a word wall or a diary or dictionary or whatever it is that you are doing so that they can go back to it. So this is one in particular that I am using with my daughter right now, who is in algebra, and she will try to remind herself when the teacher is talking about a constant. She will flip back to this quickly so that she can remember what the constant is and then go back to attending to what the teacher is saying about constants rather than focusing on, wait, which one of these things is the constant again? And then again, this is the same idea, integers. So within a general education classroom, you can pre-teach this before, right in the middle of your instruction, or at the end if you are noticing that there seems to be a piece missing for students. All right, a second way that we explicitly teach vocabulary is through explicit incidental learning. So for many of you, you probably have heard of incidental learning. Incidental learning is essentially when we learn things doing other activities. They're not planned, we just learn them as we go along in our day. Explicit incidental learning is very closely related, but as an instructor, as someone who is leading that instructional activity, we are intentionally stopping what the planned learning was and drawing the students' attention to this opportunity to learn, in our case, this math vocabulary word. So I'm going to share an article at the end that much of this presentation is based off of, but this was an example of Elizabeth had a student who she was teaching box plots in class, and the student raised their hand and said, hey, why isn't the median in the middle of the box? The box is wrong. And so in a box plot, this is a copy from Desmos, but then Elizabeth talked about how she was able to stop and review again what central tendency metrics were, what it meant to have a median, how you found the median, and then relate it back to the box plot and how it showed these different components of central tendencies. And this link right here should take you to that box plot that I created in Desmos if you have any interest in playing around with Desmos. It's very fun. All right, recommendation number 2 is to use clear, concise, and correct math language. This is probably the one when I'm talking to teachers that they are potentially least comfortable with. And so I say that preemptively to let you know that if some of the things that I'm about to say feel uncomfortable for you, you are not alone. This article up here, Supporting Clear and Concise Math Language, which again is linked in the slides, was written by my co-author Elizabeth Hughes and Sarah Powell, who I've mentioned before, and is providing a lot of explicit information about how some of the words that we use sometimes that are more informal during math instruction might lead to confusion in later years. All right, so for example, numerator and denominator. I will frequently still hear teachers refer to the numerator as the top number and the denominator as the bottom number. And then there's this line in the middle. And I think that talking to teachers and what the literature says is that teachers do this because we first introduce fractions, depending on the state, around 3rd grade. And so for most teachers, they worry that the terms numerator and denominator will be too difficult for students, too advanced for them to learn. And so they use language that the students are familiar with, like top and bottom. But the issue when we introduce the numerator and the denominator that way is we are giving the impression that a fraction is 2 separate numbers, when in fact a fraction is a number. It is the numerator divided by the denominator, which gives us the fraction. Rather than thinking of it as 2 separate things, the hope is that we get students to understand that a fraction is a number, the same way that a whole number is a number. It is written in a different way, because by the time they get to algebra, these numbers are not treated as fractions. They're just treated as numbers like any other number. And so when they see a over 6, they need to understand that that means a divided by 6. And then I put up there, so this is the textbook definition of what a fraction is. A rational number showing the quotient of 2 numbers and can be proper or improper. So I included this just to say, this is another great example of if I'm a student, and this is the definition that is shared, which is a very accurate definition. I need to know what a rational number is. I need to know what a quotient is. And then I need to have an idea at least of the difference between proper and improper. It might also help me to understand the difference between what a number is versus what a digit is. So there's a lot of information here, a lot of language that is being used to convey concepts that are all really interrelated. And so this is just another example of how the division mind map we had before, right, could lead us, as we're talking about fractions, could lead us back into that idea of what a quotient is. So common misunderstandings related to the language. As I mentioned before, when we're talking about top number and bottom number, it's suggesting that this is 2 separate numbers when in fact the fraction is the number, the quantity in and of itself. And that way we're avoiding the idea that this is a meaningless line. Okay, so when we start talking about procedures, what we see is students will get very confused when they're thinking about multiplication of fractions versus addition and subtraction of fractions, in part because the procedures are different. And if they are thinking of fractions as 2 separate numbers with a line in between them, it will be less helpful to them than if they understand that 3/4 is a quantity and 3/5 is another quantity. So this is a visual example of this procedure, right? We have 3/4, which is represented by the vertical red lines. And then we have 3/5 of 3/4, which is represented by the horizontal blue lines. And then the amount that overlaps, the 3/5 of that 3/4 represents the quantity that we get of that relationship. So we have 9/20. Another visual of this same procedure is here we have a number line. Again, we're using bars to represent it, but if I have 1/2 of 4/5, I can have students take the 4/5, which is the same thing as 8/10. They put out their Cuisenaire rod. This was made in Braining Camp. But same idea. You can do this on graph paper. You can do this anywhere. They put out their 8/10 or their 4/5. They need to find half of that amount. So half of 4/5 or 8/10 is the same thing as 2/5. So if I wrote this out again, just like up above, 1/2 times 4/5 is the same thing as 2/5. So the idea here is we're hoping to teach the vocabulary also while showing how it's related within these different concepts and procedures. All right, hopefully you're still with me. Second example, greater than or less than. The alligator is so important in the learning of greater than or less than. I probably see more alligators than any other visual of mathematics. The issue becomes that students don't generalize that as a symbol that is a mathematical representation. So, for example, I don't remember who shared this story with me, but someone was saying that they took their child to an amusement park and the sign said that only riders, and then it had the greater than sign, 100 pounds could ride the roller coaster. And the son had no idea what that sign meant because he did not recognize that as a greater than sign without thinking of it as an alligator. So again, this isn't to say that we can't use the alligator. It's just to say that we need to be really intentional and make sure that our visuals are scaffolded and we are teaching students to read those symbols as math language. So the students have to be explicitly taught that that sign on the right says only riders greater than 100 pounds may ride this roller coaster. All right. Example 3, prepare yourselves because this is the most controversial of them. Short-lived shortcuts. Short-lived shortcuts are an idea that we have a common term that it's probably the way we were taught mathematics, and then we are continuing to teach mathematics that way. And then Hughes and her colleagues have provided replacements or alternative solutions that might address the initial concern. Okay, so when we are thinking about composing and decomposing numbers, we will often say informally makes up something else, or we're breaking it apart. Unfortunately, those terms are related to the procedures and can help students get in their mind this process of making up or breaking apart. The formal language is we're composing and decomposing. So again, the idea here is we can use existing language structures like prefixes to help students understand the mathematical concept of what's going on. The second one, carry and borrow. So instead of, when we're talking about addition and subtraction with 2-digit numbers, instead of talking about the procedures of carrying something over or borrowing from a different place value, we try to use the terms regroup, trade, or exchange. And the idea behind this is we're trying to reinforce the conceptual understanding of we are regrouping things. We are not borrowing, right? My dad always made fun of me if I asked if I could like borrow a tissue. He's like, I'm not taking it back. That's disgusting, right? So think of it this way. We're not borrowing it. We are regrouping it. We are allocating it to a different location. And so the idea here is we're trying to use terms that are consistent with that. All right, another very prominent one is what number is in the tens place. So I alluded to this earlier. A number refers to an entire amount. The 4 here is a digit. So if we are going to ask the question about place value, the question would be what digit is in the tens place instead of what number is in the tens place. An alternative or in addition to asking what digit is in the tens place, you can ask what's the value of the digit 4 in the tens place, because this again is reinforcing the conceptual understanding of place value, that the digit 4 is part of the number 243 and the value of it or the quantity of it is 40. All right, and then last but not least, when adding, your answer is always bigger. And again, you can put in subtraction, your answer is always smaller. The issue is when working with zero or negative numbers, this is not always true. I was a middle school math teacher. I mentioned that before. I worked with several students with autism who were mad. I mean, they were mad. They were like, my teacher lied to me mad about this situation because they were taught this rule and then they came to my class and I said, no, that's not a rule. It's not. It's false. And so avoiding rules that expire, kind of the idea is we're trying to focus on what is mathematically happening. It might help in the short term, right? When you're teaching adding whole numbers, the idea that it's always going to be bigger is going to help because it simplifies it and it's an immediate rule that they can follow. The difficulty becomes if they're stuck in that rule, and then we have to teach them alternatives when we get to negative numbers. It becomes much more difficult. And the majority of their coursework from 6th grade on is going to include positive and negative numbers. So an alternative would be, that makes sense. We had 2 marbles. We've added 3 more. So now we have more marbles than when we started. So just pointing out the whole number combinations instead of making it a rule that shouldn't be generalized. All right. Congratulations. You made it through the language part that has alternative options. Recommendation 3 is supporting students' use of mathematical language. So the dreaded explain your reasoning question. I contemplated having like the scary monster person jump out because I think that is what happens in my son's brain when this tell how you know question comes on a math homework assignment for him. This is a random person who has posted their daughter's I just know. But I can tell you anecdotally that I see this very often. I've worked with participants, I've interviewed many of them, and they will tell me it is in my brain. They do not understand what I want from them when I am asking them a reasoning question. This picture in particular has provided the student with an inaccurate answer, and then the student has to catch that that answer is mathematically incorrect and correct that person. And so that is a very difficult thing to ask students to do. The reasoning, right, the pedagogical reasoning behind it is we want students to be able to reason through the mathematics involved here, the concepts and the procedures, and make sure that things make sense. But for some students, we're going to need to do more than just ask them to explain reasoning. We're going to need some kind of scaffolds here. So one option is a prompted writing task, and you can do the same idea spoken if that is a preferred mode of communication for a student. Many of the students that I work with prefer writing, and so we did writing as our example here. But the idea is you're breaking this down into a really specific prompt for them. So you're giving them explicit directions. What do they need to do? They need to read the writing prompt on the left, then they have to use all of the math vocabulary when they write their response. So the prompt is describe the relationship between multiplication and division, elaborate on how knowing this information can help you during problem solving. And then we've given them terms that they need to use within their response. This way, rather than just asking them, tell us how you know or explain your reasoning, we are pointing out specifically the math reasoning that we want to hear from them, and we're providing them with some options in terms of just asking them to use these vocabulary words is kind of giving them guidance of where they might want to go with this response because they know they need to use words like inverse and family. Okay, and we've also provided sentence starters like, for example, to help them with transitions. So this is one example. Again, this is in Google for you. A second option is a worked example. So in worked examples, we walk through the problem solving steps, okay? This has been done many different ways and has been effective many different ways. So this is just one type of worked example that I am sharing here, but there are many different ways that you can think about doing this. And it's a really easy and great way to build in faded supports because you can start to white out specific places where you used to have explanations for students and ask them to fill it in instead. So in this example that we have on the right here, we are breaking down the problem or the equation 3x plus 10 equals 5x. We want them to solve for x. And then we're asking what happened, what's the first thing that we're going to do, and then we're providing that mental model of why does this work. So you could do this in a group task as the teacher. You could be leading the students through this worked example together and they're writing it down with you. You could do this in terms of a small group, and depending on how you've organized your groups, you might have some groups that have more information provided to them within this table and others have potentially less information provided within this table to make it more or less difficult for them, but it provides that scaffold right there for them so that they can be thinking about what needs to happen and can potentially catch them before they solve the entire problem and they might do something incorrectly. Because if they get to a step and their step is different than my step, then they can go back and figure out why. It's also a wonderful way to scaffold homework because we know that homework, if we assign homework, that homework is most useful when students are acquiring a skill if they have some kind of way to check their work. We don't want them to go home and practice incorrectly, right? That is a waste of everyone's time. We don't want that. So homework, building fluency would be ideal. But if you need to help with acquisition, something like a worked example where they have this scaffolded support to go back to and look at to make sure that it makes sense is a really useful tool. All right, conclusion. I've left a few minutes for discussion. So in conclusion, kind of my idea here is that inclusion within the general education classroom in and of itself, in terms of placement, is not the same thing as making sure that students are accessing the curricular content that we are teaching, which means that it's also not integration in the terms of we are hoping that inclusion means full integration, right? We want to make sure that everyone is able to access the curricular content and the materials and the lessons that we are teaching. And so thinking about how we can do that for this presentation, a language perspective of how are we promoting math language is something that is very important to me. Math trajectory, we need a strong foundation. So talk with your colleagues who teach classes later and before you, right? I sat in my middle school and sat in staff meetings when the middle school math teachers were like, man, why did they not learn this in elementary school? I don't understand. And I know that the high school teachers were saying the same thing about us. They were like, why did the students not get this in middle school? And sometimes it was that the students maybe didn't maintain it, but other times I think it was a miscommunication in terms of what did our students need to really be successful at that high school level. So this idea of we need to make sure that we are preparing them both for short-term mathematics, like what are we learning, but also what are they going to be expected to do in the future to make sure that we're setting them up as best as we can and using efficient time of that instructional time. Reminder that language includes both the processing and connecting of ideas that's happening internally, but then also the expression of our thoughts and ideas. And both of these things can benefit from support. So asking someone to express their ideas or to explain something in and of itself may need to be something that you think about how do you go about doing that instead of just thinking that that alone is a learning opportunity. Same as I had this conversation with my son the other day, just because I'm sitting here saying these things to you, we know scientifically that most of what I have said is not going to be retained by most people because you have to hear things multiple times and be exposed to them in multiple ways. It's just how the human brain works. So thinking about that and thinking about how we're arranging instruction can be a way to make sure that we're helping our students the best that we can. And then last but not least, collaborate with experts. So a reminder that we have experts at our fingertips all of the time. We have general education teachers who know the mathematical content. It's part of their preparation experience. We have special education teachers that are experts in educational strategies, making sure that our instruction is effective for the students in our classroom. And then we have our families and the students themselves. They can tell you the most about that person's interests, preferences that they have in terms of modes of conversation, ways to go about learning, and ways that they prefer to communicate their own thoughts. Access to resources. Again, all of these links are in the Google Drive that you can access. And then I'll just point these out first. So this page has some recent articles that I wrote. That top one is the one that the majority of today's presentation was kind of generated from. It's an open access article, so everyone will have access to it. You do not need to be a member of School Science and Math in order to access it. Unfortunately, the one underneath, you do need to be a member, but if you are a member of DADD, which hosted our presentation today, then you can access that second presentation as well. And then if there is any of these additional, so my CV is listed there as well. If there are other articles that you are interested in learning more about, you can always reach out to me via email. All right, I will go back to discussion and question to see if anybody has questions for me or if you have something that you want to add to the conversation.
Hello. Not necessarily adding to the conversation, just confirming all of what you've said. I have a 6-year-old with autism and in the first grade, and I encountered this language problems when he had his second math test today, and I recall using the study guide for both. Every time I use the word, it looks as if I had to draw something or demonstrate somehow. But with everything you've said today, it makes a lot of sense. I recall the greater than or less than. I ended up finding the crocodile in YouTube because I needed something to make it click. And after I showed him the crocodile on YouTube, it clicked for good. So I'm just reaching out to confirm all of what you're saying.
That is great. I mean, first of all, kudos and props to you for doing all of that work to help your kid learn the math. That is just amazing. I'm glad that it clicked. That's great. Another idea for greater than, less than that I know for some of the students I worked with that would click was the idea of like you put 2 dots at the number that is greater and you put 1 dot at the number that is less, and then they connect it that way, and it for whatever reason can help as well. And we'll use manipulative sometimes. We'll stack like Unifix cubes, and then I use popsicle sticks to connect them to show the magnitude difference between greater than, less than. So it's wonderful to hear that these strategies are working for students and that you are able to access them. So kudos to you. That's great.
Dr. Cox, I have a question that's sort of along those lines. I think that was a parent who or caregiver who just kind of made that comment. So could you talk a little bit about strategies for teachers to sort of help families engage in implementing some of these practices, right? Like we talk a lot about generalization across settings, and I know oftentimes caregivers are overwhelmed when they're supporting students with mathematics. So can you talk a little bit about how teachers might be able to help in that translation of implementation of strategies in home or community-based contexts?
Yeah, that's a great question. I mean, I guess the first thing I will say is it sounded to me as well that it sounded like that was a parent who made that comment. And again, I think that it is amazing that they were able to do that. I know that not all families are in a place that they can. And I do think that our schools have a very large role in supporting students. So when we see students who those concepts are not clicking, when greater than, less than is not clicking, or we see performance that, especially if they were doing well previously and suddenly something happens, it should be an indicator to us immediately that something might not be clicking in the same way that it was before. And so I think the first thing I would say is to and I think this is really hard because there's like systems level things that obviously teachers have absolutely no control over or little control over. But as a classroom level teacher, the first thing I would say is the awareness piece. Like, just be aware that for many students with ASD, their performance in early grades in math is likely going to appear strong, but keep your eyes out for the underlying, the math language part of it, the reasoning. Make sure that that is a really solid foundation so that as they move along, they are continuing to be successful and they have that really solid foundation built. In terms of reaching out to family members, I would say the next piece is I think it's really important to share what you are doing at the classroom level to build what Dr. Pearson was saying there in terms of this is a coexisting relationship, right? Yes, we want students to be able to use this information in multiple environments for generalization, and we are doing this together. And so some of the successful ways that I've seen this happen are if we do have students make things like math dictionaries, they can bring them between the two locations. If the teacher is able to record quick little videos introducing what a specific term is, particularly if it's a term like numerator and denominator, that the families may, that's not the way that they learned probably, right? And so if you can make a quick video explaining to the family how you are using it in the classroom and explaining why, it can often go a long way either for that family to understand where you're coming from or the importance of it, and for the student to be able to access it in multiple environments.
That's very helpful. Thank you.
Of course.
It looks like Chessie, if I'm saying that correctly, might have a question.
Yeah, not necessarily a question. I was going to add to the question that to the response she just gave. When my son was in kindergarten, what the teacher did was whatever I did at home that worked for him, he shared it with other parents who had similar concerns. Because I always, I would show her the YouTube videos I use. I would show her I would send her small videos of what we are doing that is working. And sometimes she would tell me that, is it okay for me to share it with other parents? I'm like, sure. So sometimes, you could share something. And in kindergarten, actually, he's much better now with these concepts in first grade. In kindergarten, I had to go to YouTube and look for somebody teaching that concept who is Caucasian, so that he sees somebody like his teacher, but me explaining it. So I had to go that route to get him to understand. I'm like, that's your teacher, and listen to what she's saying, then he gets it. And sometimes even with the accent, it becomes a little strange. I have to use Google Pronounce to pronounce the words the way he will hear it from his teacher. So I do all of these things to make sure that he can be present in class and not just sitting there.
Yeah. Yeah, that's a really great point. Thank you for bringing that up and explaining it that way. I think if I can add to that, I mentioned before that the amount of research that we have is limited. And so as much as we can work together and learn from one another and understand all of these contexts with which families are working, it's very important for us as a field, for people like me who are doing the research and then trying to share that research, right? It's so important. So thank you for being here. Thank you for sharing.
Any other questions for Dr. Cox?
It's a little
Not
bit of a
quite. Not quite. I was just going to say that I bought a lot of books from Barnes and Nobles, but they didn't help me with the problem until I looked for other ways to do it.
Mm,
Yeah.
right.
Yeah, that's interesting. Yeah, I mean, so again, you have access to my email here. If there is ever a time that you have a question or there's a particular resource that you are looking for, if you want to send me an email to save yourself from having to Google search it, if it is something that I can provide or point you in a direction, I am more than happy to do that. I will also, if I don't know, I will either call on my brilliant colleagues or share that I don't know and try and get an answer for you. So yeah, please feel free to reach out. Because yeah, I do. I think it is important not only for everyone here and all families to have access to, and teachers to have access to high quality materials to help our students, but I do think that it's important for us to know that these things are happening and to be able to inform the field and the literature and think about it. Because for me at least, a lot of the general education literature is talking about teaching math in a particular way. And that way often does not align with many of the strategies that show up as evidence-based practices for students who are on the autism spectrum. And so that leaves this very gray or odd area of, is this in fact working or is it not? And what are we going to do about it? And so the more we hear from people, I think the easier it is and the more compelling it is when we're talking to people who are making decisions about why this is so important.
Absolutely. Thank you so much, Dr. Cox. I do want to be mindful of time. We have about 1 minute left. Any final questions or comments? We do have just a couple other things to share on behalf of the committee as well.
Is there a way that you could repeat what you said about inclusion and access and integration not being equal? I got the first part of it, but not all of it.
I'm not going to be able to repeat it verbatim because,
I know.
but
That's what you can.
so the idea essentially is that when I think of inclusion and when I hear teachers and school administrators talking about inclusion, inclusion is often conceptualized as physical placement in a classroom. And so my kind of argument here, or my I'm going to leave you with this musing, is that physical inclusion or a student being placed in a general education classroom is not in and of itself access to the curriculum, because we can't guarantee without additional supports and scaffolds and data collection that the student is in fact benefiting from the material the way that it is being taught. So, and therefore that means that they are not necessarily being successfully integrated within that class, whether it is from the receptive point of the language, like are they able to receptively receive that language, process it, understand it, make it prior connections, and are they able to successfully communicate that reasoning with their teacher, with their peers in expected ways? And if the answer to either of those is no, or not as much as we would like them to be, then my argument is, okay, well, then we have an obligation to support that student, because that's what inclusion is. Inclusion is access to the general education curriculum and complete integration within that classroom environment. Does that answer your question?
It does very much. Thank you.
All right, perfect.
Thank you so much, Dr. Cox, for such an informative session. I know so many, students that we work with are often, pre-service teachers are often intimidated when they're thinking about mathematics instruction. And so I really appreciate the way that you present these strategies and evidence-based practices to support students on the autism spectrum. So we're really grateful that you were able to kick off our fall series of our DADD Diversity Committee community chats. And I just want to do a quick pub for our next chat. Dr. Lori will be doing a presentation in November. So this one is on November 12th at 3 p.m. Eastern Time. So we'll send out additional reminders in the coming days to register for that, but you can also see the information on the screen. So we're really excited to have Dr. Catherine Lori, who will talk a bit about additional strategies to support students with autism. So again, thank you so much to Dr. Cox for this wonderful presentation this afternoon.
No, thank you all. Thank you for joining me for this math presentation. So happy to have faces here. I appreciate all the work that you are doing.
All right. Thank you, everyone. Hope to see you in November.
Thank you, Dr. Pearson.
Of
Thanks,
course.
everybody.
Bye-bye.
Thank you.